Good afternoon, students. So in this video, we are purely going to go over some vocabulary. So there will not be any practice questions. I'm not going to write anything down because it is a little wordy as we go through these things. So what we're going to do at the start is if this is your second time watching the video, you can pause it, copy down what you see on the screen. I will also in a moment go so you can see the little bit at the bottom here to copy down, and then you can kind of just listen through and kind of follow along with what I'm saying. So that way you don't have to write anything down as I'm explaining each section. So go ahead and pause what you see here. Okay, something else I want to point out, if you already copied it down, I color coded the sides here, 3 different colors. If you like color coding, you could do that too. It kind of helps you visualize what are known as corresponding sides. We'll get into that in a moment, but that's extra. You don't have to do that. And then there is one more thing down here at the bottom. So if you did not copy the second piece of information, there's the second, and then here's the third. Okay, so let's discuss what are known as similarity terms. So when something is proportional, that means when quantities have the same relatively similar size. So we have talked about proportionality when it comes to numbers. So if I am making a batch of cookies, if I want to triple the batch of cookies, I have to make sure that I proportionally triple the amount of flour, the amount of sugar, the amount of chocolate chips, so that way I basically make the same exact cookie just in a bigger batch versus a smaller batch, right? It's important. We also have proportionality when it comes to shapes. In one of the other videos I discussed, if you were to copy and paste a picture, and you want to increase it, but have the picture, look the same. You don't want it to look distorted. You typically drag and drop the corner of the photo, right? So that way the length and width are proportionally being increased or decreased by the same amount. If you only move one side or the other, the picture becomes distorted. So when we're looking at shapes, something that's interesting about shapes is what's known as similarity. So there are similar terms that are going to be really important for kind of the future. And when we talk about proportionality amongst shapes. So when we're looking at 2 shapes, all figures that are considered similar or all similar figures must have, and there are 3 things that they must have in order to be considered similar figures to each other. The first thing is they need to have the same shape, but they need to be different sizes. So they need to be the exact same shape. So they both need to be equilateral triangles, or they both need to be isosceles triangles, or they both need to be right triangles, or they both need to be rectangles, or they both need to be trapezoids, or they both need to be right trapezoids. They have to be the exact same shape. They just have to be different sizes. One has to be larger, one has to be smaller. The second thing is they need to have corresponding sides that grow or shrink by the same multiplier, which is called the scale factor. So I have drawn 2 right triangles and I have labeled their sides. So this one has a 3, 4, and 2 side. This one has a 6, 8, and a 4 side. So I kind of color coded them. So this side of 3 corresponds to this side of 6. This is the same side of the triangle, just this is the smaller version and this is the bigger version of the triangle. And then same with the other 2 sides. So if I was to compare the lengths or the measurements of each side, they need to kind of either increase or decrease by the same amount. So I'm going from, if I kind of look at these shapes from left to right, I'm going from a smaller shape to a larger shape. So obviously I want to make sure that each of these measurements is increasing by the same amount. And again, with proportionality, we're either multiplying or dividing. So if I'm going from 3 to 6, that means I'm being doubled, right? I'm being multiplied by 2. If I'm going from 4 to 8, because these are the corresponding sides in the triangle, I am also doubling. I am going, times 2. And then from 2 to 4, same thing, I am doubling. So all of these are increasing by that same amount of 2, and that's known as the scale factor. This shape was increased in scale by twice its amount, and we went from a smaller to a bigger shape. So in order for 2 shapes to be similar, this whole thing has to happen. They have to increase or decrease by the same amount. Everything was proportionally increased by 2. If something was different, if this was tripled, or if this wasn't completely doubled, then these 2 shapes wouldn't be similar. They would look alike, but they wouldn't be classified as what's known as a similar figure. Okay, And then the last thing is all of the corresponding angles have to be congruent to each other. Congruent means the same or equivalent. So in the triangle, I drew another right triangle and I labeled it A, B, C, and D, E, F. Okay. So angle A and angle D and these two triangles, they need to be the same measurement. Like they both have to be 30 degrees or whatever. Okay. This is a right triangle, right? So angle B and angle E both have to be right angles or 90 degrees. And then angle C and angle F, they also need to be the same measurement to each other. So 60 degrees, 45 degrees, whatever it's supposed to be. So if the angles are not equivalent or congruent to each other in the two shapes, then they're not similar figures, because then it's not, the mini version of this shape, right? Or it's not the larger version of this shape, because the angles are going to make a triangle that looks slightly different. So the way that we would determine if something is similar, especially let's say we're talking about a triangle, this is saying triangle ABC, so this triangle, and triangle DEF are similar to each other. And the symbol we use for similar is like a squiggle. I kind of like to think about it as like a sideways S, because similar starts with S and then it's like a sideways S on its side. So if I wanted you to write those two triangles are similar, you would kind of label what the triangles are, and then you would use this squiggle to write the word similar. Or if I gave you this and you were like translating that math like stuff to English, that's saying those two triangles are similar to each other. That's the symbol that we use. So kind of the key vocabulary words I underlined in here. So corresponding angles, congruent, corresponding sides, scale factor, similar. Those are all kind of words I'm going to use in the next video. Because basically what we're going to do is we're going to apply what we know about solving proportions to a shape. So basically, like if I give you two sides of a shape, and you need to figure out the third side, and I tell you that it's similar to this figure over here, you can use proportionality, or what we know about solving proportions, to solve for the missing side, which is it's kind of cool. It's like geometry and equations in one, a little bit. So if you have any questions, I would just Google similarity vocabulary or similarity terms, and you can find a lot of videos on YouTube or a lot of places online where they kind of maybe go a little bit more into depth, but these are some of the terms that you need to understand and that I'm going to use in the future. If you have any questions or need something explained in further depth, please feel free to ask your teacher, and I hope you all have a good day. Bye.